2m second derivative dt squared plus b first derivative plus k y equals to 0. So if we solve in it, then solutions for R are going to be 2m on the bottom, negative b plus or minus square root of b squared minus 4m. Okay, right? So it's roots. Okay. So we have it underdamped. Underdamped. We have it underdamped means the system will be oscillate, and in our case means complex roots. Because the system will keep on oscillating, it doesn't stop, which means if look what is going on is if you look at our roots, then R1, 2 equals negative b divided by 2m plus or minus, and that is going to be complex. So e squared minus 4mk divided by 2. Okay, that's supposed to be a complex number. Imaginary. So that's supposed to be imaginary. Okay, so R1, 2 equals to alpha plus I beta. And if you like, alpha is going to be negative b divided by 2m. And beta, if you simplify that expression, I guess if you don't want to, you don't have to simplify it much. 4mk minus b squared divided by 2. Okay, so that's the thing. Then our solution is going to look like y of t e to the negative alpha t c1 cosine of beta t plus c2 sine of beta t. We already know that. And that's exactly what we expect to be happening here. Right? So when time is approaching infinity, what is happening? That e to the negative alpha t will be approaching 0. So y of t will be approaching 0. Okay? So eventually our amplitude of oscillation is going to be decreasing. If you like, we can do the same thing for this guy as we did before. So y of t equals e to the negative alpha t sine of beta t plus phi and a here. So we can do the same thing as we did earlier with this guy, right? And rewrite it this way. Doing exactly the same thing as we did earlier, right? So the only difference is instead of omega, we have beta. So you can rewrite it this way. And if you look now, what is that expression tells you? It tells you how the picture is going to look like. So in general, the situation will be happening here. So we kind of have at e to the negative alpha t And our oscillation will go start somewhere and will oscillate. And amplitude of oscillation will be getting smaller and smaller and smaller. So it's going to oscillate between those boundaries which is set by this guy in front. Okay, e to the negative alpha t times a. So let's dampen factor. A times e to the negative alpha t. Because that's the thing which will make those amplitude to decrease. So that's what is happening when we have underdamping situation. So let's underdamp. Let's under. Let's underdampen. Overdamped. Overdamped situation when we have two real roots. When we have two real roots, R1 and R2, which are negative b plus or minus so for underdamping, we have b squared minus 4mk to be less than 0. For overdamped, we have b squared minus 4mk positive. Okay, so we have two roots. So we have our solution, y equals c1 e to the r1t plus c2 e to the r2t, where both r1 and r2 less than 0. You can do the calculations, you can check that, because of our formula negative b, and negative b is going to make everything negative. So r1 and r2 negative. So when our solution might look, we have three possibilities. It might look like this. So no critical points. It might be pushed a little bit below, but then it's stabilized, so it will have mean. Or the third picture, it might be pushed upward and then stabilized. Okay, so we might have only mean, only max, or no max, no mean. Those are three possibilities. So it will do at least one oscillation and then just stabilize. It's kind of a bit weird. And critically damped situation, critically damped. When we have R1 equals to R2, that is when that's square root of b squared minus 4mk equals to 0. So then y equals c1 e to the r1t plus c2t e to the r2t. That's solution for critically damped, and its picture similar to overdamped. So if you consider what we got as a solutions, then it's a bit weird, at least the way I find it. So system will either go up and down, up and down, up and down, up and down. forever, right? That's what we put for underdamped situation, or for overdamped or critically damped. It will do it at most once, and then that's it. Okay. So it will either keep on bouncing, or it will bounce once and then sit. Okay, that's kind of a bit strange.